Okay, so for synthesis, this is the general form of the equation. A plus B makes AB. We have one product on the right side. We can always recognize a synthesis reaction because there's only one product on the right side. If we were going to look at the opposite, the decomposition, we will always have one reactant on the left side. That's why they're opposites. One's breaking down, one's putting together, and they're opposites also because I have a reactant on the left, just one. And back on our synthesis, we have one product. So that's one of the easier ways to deal with that. We're joining a metal and a nonmetal together. And when a metal and a nonmetal join together, they form what kind of compound? Ionic, yes. And so when we join these two together, they will make, what's the name? What would be the name of the compound? Let's name it. Calcium oxide, right? We do not change the name of the metal, and the nonmetal becomes IDE. So I think sometimes it's easier to go ahead and try to do these with names, and then once we have the name, let's figure out the formula. What they asked us to do, and I want to make note of that, we want to write and balance each equation. And over here on the decomposition, it doesn't say it, but we do want to write and balance. We're going to do the same thing. Okay? So, the formula for calcium, or the symbol for calcium, is Ca. Put a little space in front. And for oxygen, what are we going to put down? O2. It is one of our diatomic elements. When it's alone, it has its twin. It has to be O2. These two are going to join together to form calcium oxide. In any ionic compound, we base their ratios on what? Starts with a C. Charge. Thank you, whoever said that. Good job. We base it on the charges. The charge of calcium is a 2 plus. The charge on oxygen is a 2 minus. So our formula is CaO. I want to emphasize, because I see this happen all the time, and it happens quite often, and then we start getting confused. Just because I have a 2 over here on this oxygen does not mean the 2 gets carried over. We do not carry over the subscripts. The subscripts are there to help us combine charges, or to tell us the ratio in which they combine. It has nothing to do with what's over on the left side. Please make note of that, because I see that happen often. And once you start making that mistake, it happens over and over and over again. We'll take care of the various numbers, what? By using coefficients to balance. That's how we'll take care of that situation. On 2 and 3, we felt it was important to go ahead and give you our products, because on this reaction, it could be copper 1 or what? Copper 2. Doesn't copper have more than one charge? So you would not have any idea which one it should be. So we gave that one to you. You should be able to write that one up. You've been doing that for the last day and a half, right? And here is the type of reaction. Any type of metal oxide in water is going to form calcium hydroxide. We're not going to expect you to memorize that. We're just helping you out with that one. Okay? You should be able to take care of that one. This one, number 4, is called the Haber process. It was important for making fertilizers and explosives back in the day. I think we already had this in one of the previous problems. So hydrogen and nitrogen make ammonia. Not ammonium, ammonia. So let's go ahead and we'll work this one out. Hydrogen. What am I going to write for hydrogen? H2, it's one of our 7 diatomics. and nitrogen. Say it. N2. And then I'm not expecting you to memorize this. Ammonia is close to ammonium. It's going to be, instead of NH4 plus, it's going to be a NH3. It's what you smell in your cleaning solution sometimes, ammonia. Once you smell it, we'll have it here in the lab sooner or later. You'll know what it is. And on number 5, just treat this as a metal and a non-metal joining together. Okay, kind of like what we did for number 1. Okay, now let's get to our decompositions. They can be a little bit more complicated. They don't have to be. There's a slide. There's a slide in the agenda that focuses on just this portion, just the decomposition. Predicting products for decompositions are a little bit more difficult, and we're not going to ask you to memorize all these various types, okay? But we might give you a problem and then give you a hint. Like right now, we're going to deal with metallic carbonates. Any metal carbonate is going to break down and form the same metal oxide and what? Carbon dioxide. So I know that's a little confusing. Let's take a look at barium carbonate. Is that a metal carbonate? Is barium a metal? Yes. So it's a metal carbonate, right? And we said, according to that situation, any metal carbonate is going to form a what? Metal oxide and carbon dioxide, right? So what would be the metal oxide? Barium oxide, yes. It's the same metal. We're just changing it from a carbonate to a oxide and carbon dioxide. I can't even write with this pen. Sorry, I made it too large to see. There we go. So any metal carbonate will decompose to form a metal oxide and carbon dioxide. I don't know why I have, oh, that is an I. Sorry. So, metal oxide. Metal carbonates, any metal carbonate forms a metal oxide and carbon dioxide. So let's put it together. Barium, what's the charge on barium? 2 plus. Carbonate, the ATE says it's a polyatomic ion. So what is it? Should start recognizing some of these. Okay, CO3 with a 2 minus. When we combine those together, what formula do we get? Ben, you with us? BaCO3. And again, we do have to balance those, right? And most of the time, in order to decompose something, you're going to have to put some heat to it. You're going to have to heat it up. We'll do that in the lab coming up. You'll decompose, I think it's going to be copper carbonate. So it'll break down, and it's going to form barium oxide. Again, barium is a 2 plus. Oxygen is a 2 minus. So it's going to form BaO, and you know what the formula for carbon dioxide is, CO2. So when I talk about, nobody's going to ask you to memorize that carbonates make the oxides and carbon dioxide. But if I gave this hint to you, I would expect that you could take this and tell me the products. Okay? Are we somewhat okay with that? So is this a carbon? This is a carbonate, right? This is the carbonate. So what we're going to do, this is going to be magnesium oxide and carbon dioxide. This is going to be what? Potassium oxide and carbon carbon dioxide, right? Same pattern every single time. Okay, last one. Let's go down to the zinc hydroxides. So zinc hydroxide forms, if we look at its hint, the metallic hydroxides form a same thing, right? A metallic oxide. But this time, instead of carbon dioxide, it's water. Well, H2O. So my zinc hydroxide is going to form what? What formula do I have? It's going to make it metallic oxide. So what's it going to be called? Zinc oxide. But instead of it being carbon dioxide, it makes water. So zinc is a 2 plus, hydroxide is a 1 minus. You should have done plenty of these by now. So what's my formula? ZnOH2 makes the zinc oxide. So this is a Zn with a 2 plus, oxygen is a 2 minus, ZnO, and H2O. Now, before I just let you start working, again, let's take a look at this one. This is a 3 over here, this is a 2 over here, okay? We don't carry subscripts. Everything is based on, if it's an ionic compound, it's based on their charges. Yes, they combined a 1-to-1, 1-to-1, but when we went down here, this is a 1-to-2, and this side's a 1-to-1. So again, we're not carrying over the subscripts. Treat them differently. So the one under it, iron hydroxide, is going to be iron 2 hydroxide is going to make iron 2 oxide plus water. Okay? So what do we got time-wise left?